anomalies, and more. Data is the oil of our generation. Data science is becoming indispensable in today's digitally driven life. Without further delay, let me invite first Dr. Kumar, respected principal of Triveni College, Raniganj, to deliver the welcome address. Sir, if you kindly take over from here on, please, sir.
Very good morning to one and all. At the very outset, I welcome all of you. I am very much delighted with the fact that the Department of Statistics and Career Counseling Cell of our college organized a webinar with the IPAC of our college on the topics of application and prospect of data science. Actually, the topics which is very much interesting and relevant in the present scenario. I have a great proud privilege to welcome Professor Dr. Sadhan Chakraborty, Honorable Vice Chancellor, Kazi Nazrul University, Asansol, for giving his consent to act as the inaugurator of this webinar, in spite of his busy academic schedule. It's my great pleasure to welcome Professor Bimal Roy, Chairperson, National Statistical Commission, Minister of Statistics and Program Implementation, Government of India, for spending his valuable time as a resource person at this beautiful webinar. A warm welcome to Mr. Abinash Adhikari, founder and head of data science, Global Stat Academy, for his towering presence at this seminar. I take the opportunity to welcome Mr. Saikat Mukhopadhyay, senior expert, data science, robotics, and also Ms. Srijita Bose, deputy manager, advanced analytics team, Delegate. I also take the opportunity to welcome to all the participants, like teachers, scholars, students, and other of this seminar. A warm welcome all of the research persons, honorable vice chancellors, and other participants on behalf of our college. Actually, data science is much more relevant in the present scenario. Data scientists have to develop and install statistical tools. It helps in building predictive model. This model support clients in consumer marketing and demand generation initiatives. Apart from the application of data science is also used in marketing, finance, human resource, healthcare, government policies, and every possible industries where data gets generates. So I hope and believe that this webinar will succeed with all its objectives. I'm sure that this will be a rewarding venture for all of us present here. Before I end, I again welcome all of you. Thanks.
Thank you, sir. Thank you very much. Now I invite Respected Professor Shadhun Chakraborty, Honorable VC of Kaji Nazrul University, Asansol, to deliver the inaugural speech. Sir, if you kindly take over from here on. Please, sir. Sir.
Thank you for inviting me to this program. I sincerely congratulate the respected principal of TDB College and the organizers of this program. TDB College, I have seen in last few years that do not want to organize seminar of low profile. They always organize seminars of high profile. I'm really proud of this college. Data science, as it's told by our respected principal sir, that it is extremely relevant and important in our days, and the esteemed speakers of this program will elaborate on different aspects of data science, and the participants will interact with them, I hope, and through the dialogue between the esteemed speakers and the respected participants, all of us will be benefited much and enlightened about data science. Data science, as it is evident, that it involves two terms, data and science. And both of these two terms important, and both of them are keywords. Many things come in our mind, but we do not succeed in articulating everything which comes in our mind. Data science helps in articulating whatever comes in our mind. And this is a great achievement of data science. Unless we can articulate data, we cannot proceed further. So it is extremely important aspect of data science, and using different programming languages like Python or R or many other advanced programming languages, we can articulate data which will be useful for our purpose, the purpose with which we are engaged in different areas, different projects. And another aspect of data science is programming, using those data after cleaning of them. So by using relevant and effective programs, we can give answer to the questions with which we are engaged in different projects of our interest. Its application and prospect, now it is almost known by everybody. All our intellectual activities, all our intellectual behavior, it may be in the area of business, it may be in the area of different kinds of industries, it may be in the area of service, service sector, it may be in the area of research, academic research. All intellectual activities now is impossible without data science. We cannot produce significant output without data science unless we articulate data properly, unless we analyze data properly, unless we run appropriate programs, we cannot arrive at conclusions which we seek in different areas. So through this dialogue between the eminent, esteemed speakers of this program and the participants, I think the Devi College will be able to publish certain articles or books, anthologies of high quality. I wish a grand success of this webinar and declare the academic sessions open.
Thank you. Sir. Thank you very much. It gives me immense pleasure to introduce the honorable speakers of today's webinar. Today, at first, we have amongst us Professor Bimal Kumar Roy, Chairperson, National Statistical Commission, Ministry of Statistics and Program Implementation, Government of India. After schooling from Narendrapur Ramakrishna Mission Vidyalaya, he joined Indian Statistical Institute, Kolkata, where he obtained BStat and MStat degree. Thereafter, he received his PhD degree from the University of Waterloo, Canada. He has been a faculty member at Indian Statistical Institute, Kolkata, for past 36 years and was its director during 2010 to 2015. Currently, he is the head of Bose Center for Cryptology and Security at the same place. The awards obtained by him include Padma year 2015, INSA Teachers Award year 2014, IBM Faculty Award year 2007, NASI Reliance Platinum Jubilee Award year 2007. He has supervised 20 PhD students across the disciplines statistics, computer science, mathematics, chemistry, and environmental science. Sir, please, we are eagerly waiting for your most valuable speech. If you kindly take over from here on. Please, sir. Sir.
Okay. Okay. Thank you. You're Rajashree, right? Okay. Thanks, Rajashree. My respect to start with the principal and the vice chancellor, and also thanks to all the organizers, and especially my old-time friend Padmaja. Actually, she was my 1 year junior at ISI, and also a good friend of my wife. My wife was a student there, and she pursued me to agree to this webinar, which I agreed. If she says I cannot say no, so I have to agree. And this topic also is very relevant. And the way I will talk about it is little probably unconventional. I will like to get to some concepts through certain experiences, certain stories. Okay, so as Honorable Vice Chancellor, Honorable Principal mentioned, that playing science with data. As it looks like, science is a very vast term. Data is again another vast and probably a little vague term also. I don't even quite understand today what is data. So Let me start with the first story. It's not me. This is a well-known story in the statistics domain. The father of statistics, Sir Ronald Fisher. So he was teaching in Cambridge, and he was teaching a simple concept like correlation coefficient. But now this because at that time things are being developed. This is more than 100 years back, and he taught correlation coefficient in the class to the students. He defined the concepts. He worked out the formula. Then he showed that this is from 1 to +1. It is two variables, two attributes x and y. 1 means x perfectly determines what is y. -1 means it perfectly talks about just the reverse of y. And 0 means x and y has nothing to do with each other. And if it is positive, this means if x increases, y also increases. If it's negative, if x increases, y decreases. Okay, and all these formulas were done. And then he told the students, this was 1920s, to go to the library. Remember that time there was no internet. So collecting data was a challenge. So he asked the students to divide into two groups, go to the library and look into the quarterly bulletin of two ministries. So each ministry would publish a bulletin in every 3 months about their activities and all the information pertaining to that particular ministry. So he talked about two ministries. One is the Ministry of Commerce, and the other is the Ministry of Social Welfare and Justice. He told the first group, you should pick up the last 30 years, all the quarterly bulletins of Ministry of Commerce, and just copy the amount of apple export. Okay, so the students went there, they divided among themselves, they looked into all these 30 years times 4, 120 quarterly bulletins of the British government Ministry of Commerce, and they have copied. This is the year and quarter, and this is the amount of apple export from UK. So they came back to the next class. Data set like Q1, Q2 up to Q120, and the amount of apple export as recorded. And the other group was to pick up the bulletin of the Ministry of Social Welfare and Justice. And they were asked to pick up the data on number of registered divorces. Okay, so they divided the work amongst themselves, and they looked into these bulletins, and for each of these 120 quarters, again they picked up the year, quarter, and the number of registered divorces. So he puts this together. Q1, amount of apple export, number of registered divorces. Q2, amount of apple exports, number of registered divorces, so on and so forth, up to the Q120. So you have a nice data set. This is data. So the first column, first attribute is apple export. Second attribute is number of registered divorces. And then he asked, okay, compute the correlation coefficient between these two. We already worked out the formula, very simple algebraic formula. If you are doing statistics in the very first semester, we teach correlation coefficient. So even in other subjects, you have to learn correlation coefficient. So they compute the correlation coefficient.
ঠিক আছে শুধু অডিওটা অফ করে রাখো
The correlation coefficient comes to something like minus 0.87. Well, what does that mean? Minus 0.87, very close to -1. This means if you have to make a recommendation on the basis of this information on the given data, that you have to, if you have to decrease the divorces, you have to increase the amount of apple export. That would be a data science oriented recommendation to the government. And if you have to decrease the divorces, which could be an objective, and you have to increase the apple export. Or any child would laugh at it. Okay, this is nothing could be more ridiculous than this one. But then what is the problem here? The problem is that we did not understand the domain quite well. So we have to have some prior idea about the domain, how what the attributes somewhat related. We have to understand the attributes very clearly, the perspective, the kind of I think population where you are trying to get the data and so on and so forth. And unless you understand the domain correctly and deeply enough, a scientific stuff there or statistical work on there would lead you into horrible, misleading, sometimes even bogus information, inference. So I start with this caution before anybody does data science. And these days I'm getting more scared because there are so many tools. Okay, so many tools for data science, and the tools has actually developed some program, some algorithm implemented. It doesn't depend on the domain. It doesn't tell you about the domain. No. Now you collect data from some domain and put input to this particular tool. Something will come out. You put any damn thing, something will come out. And if you want to interpret that way, that could be a disaster. So I start my talk with the first strong advice or suggestion that don't ever use any data science techniques tools unless you understand the domain of the data. This is very, very important. This is my first story. The second story is so I didn't know this term data science. So we studied statistics, and suddenly in the last 10 years or so, we're talking about data science. What is the basic difference from statistics to data science? There is some difference, otherwise we could call it statistics. So I tried to understand what is the difference between statistics to data science. So then I realized that data science also, given some data, we want to make some inferences. We're going to understand data well enough. So this is something like understanding the scenario and scenario. Okay, and then from there we want to possibly project or predict about near or distant future. That's what data science do. That's what even statistics does. So what is the issue? Why they are different? Then I had to find out there is a sharp line of difference there. In statistics, what you do is basically we try to, suppose you are trying to estimate certain things. Then you try to have a model, and from the model you do a lot of algebra, and then you try to get what we call a closed form expression for the parameters of interest. But often I have seen number of variables, if it becomes very large, number of observations, if it becomes huge, working and the scenario, the background becomes so that often the complex scenarios, I cannot get a closed form solution. If I could get a closed form solution, this is a formula for this estimate of this parameter. This is a formula for what would be the value of this 2 hours from today or 2 years from today. I could get a simple formula using a model. Then my job is well done. But that's not the case. And we have seen that mostly when the number of parameters of interest, called variables, and the amount of data becomes huge, also changing criteria for what is a good inference. If it's more and more complex, it's extremely difficult to find what we call a closed form solution. So actually statistics somewhat fails in certain scenarios. Then do you stop? You don't stop. So what we try to do? We try to have a roundabout way and see if we can still handle the problem. Okay, or maybe we could do some other non-statistical way try to see if you can handle this data. I'll give certain examples later on. So this is where I'll give an example for statisticians don't know. We often compute inverse of a matrix. You see in all the formulas, you'll find a sigma inverse. Variance coefficient sigma. Formula nicely writes sigma inverse. But then sigma inverse sigma, the dimension of sigma is E by P. E is basically the number of attributes you consider. And if you think of computing sigma inverse of a matrix, you try to compute anything beyond 10 by 10, no computational algorithm will give you a correct answer. The reason is, when you compute this inverse, we do lots of divisions. And when you do divisions, there is an error. And this, if you do more and more division, this error accumulates. So if you go beyond 10 by 10 matrix or say 20 by 20 matrix, then you will end up getting so much of error. Ultimately, sigma inverse you get is far real sigma inverse. Okay. So in that case, nothing can work out. So what you try to do? Something like an iterative solution. Okay, so start with some beliefs, certain initial solution, and then try to design an iterative method. I don't know whether you have done it at some point of time. In numerical computation, we have done it, like Newton-Raphson formula for interpolation or something. So what we do, we start with a solution, and then you just try to modify your solution depending on certain properties of the data, and this iteration goes on, and kind of you expect that the values between two iterations, if they don't change, you have reached the exact solution. So this is what we will call a heuristical method of solving this problem. But there are two issues. One issue, this iterative method. First question is, does it converge? Unless I can show that it converges, this useless thing. So you start, it never converges, I never get the solution. So first thing is, does it converge? Iteration. Okay, and if so, this is a mathematical question. Does this method converge? And this, you can think of the Newton-Raphson method for finding solutions of, I think, roots of an equation. You would find that it may not converge, but it is a certain condition of convergence. And if it converges, how long does it take to converge? How many iterations maybe I have to do before I get the convergent solution? Do I do trillions and trillions of iterations, or thousands and thousands of iterations? If the number of iteration needed becomes so huge, in that case, this method is again going to be useless. So we have to study the convergence and what I call rate of convergence. So we first try to get in data science from statistical solution. If that is and which is also computable within the given computing facility, I would still say that is the first step to do. If you do it, done. Otherwise, we go into some iterative solutions, and if you do some iterative solution, you have to also establish that this iteration actually stops. That means I get series in my solution. Once I can establish that this converges, I have to also know the rate of convergence. That means how long it may take to converge. 2 minutes, 2 years, hundreds of years, and so on and so forth. So this analysis has to be done. But this is what I will broadly say now, data science, something that goes beyond statistics. Now let me talk about a few examples where I have used this data science. The number one example is you are in Raniganj. So think of steel plant. They have a manufacturing process. There are so many steps, and then everything gets into the blast furnace. And from the blast furnace, the liquid form of steel comes out. So I was trying to understand this entire manufacturing. I realized, in fact, the MD of Jamshedpur plant, or I think Odisha, there is some other Tata plants I visited. They said that sometimes this blast furnaces stop functioning. What does that mean? That suddenly you see that it's no more working. Now they have a good set of very efficient and competent engineers. Immediately the engineers will get into the problem, they'll work out what is the problem, they'll fix it. But it may take 1 hour, it may take 2 hours, it may take 4 or 5 hours. And for every minute of blast furnace being stopped, the financial loss is huge. You can't even imagine. So it actually goes. So if it stops for an hour or 2 or 3 or 4, the loss is huge. So what they are trying to see, is it possible to make a kind of a little prediction ahead of time, that something like I could tell that within 2 hours or within 4 hours, there is a good chance that this blast furnace may stop functioning. Say I say with probability 0.8 or probability 0.9. It's a big if, but if I could do that, then what the manufacturing process will do, they will immediately get the engineers in work. They won't wait for the blast furnace to stop. Even if the probability says 0.8 or 0.9, you can think of any threshold. If it exceeds certain threshold in the probability, then immediately they get into the entire system parallelly. Manufacturing the process is on, but they're looking into other things. So what are these other things? That's what is again data science. What data they need. So they try to figure out what are the parameters in this process that may disturb this blast furnace functioning. And I think they figured out about 60 such parameters. I'll tell you some. In the ore that is fed there in the process. Ore has got many different components. Now the contribution of each component is an input. Okay, it might so happen a certain kind of input, if it gets more or less, the production process is affected. Okay, then temperature at various level of this manufacturing, this process. They push air from outside, the air pressure, okay, at various of this one. Likewise, this is what I call the understanding the domain. So the engineers found out that these are the possible things that might affect this manufacturing, which will lead to total stoppage of the procedure and the blast furnace stops working. Now then, what data do they need? So they have actually installed some 60 odd or 60 plus sensors, which collects data of all these parameters at every 10 minutes interval. Okay, and that is passed to their main official control room or whatever it may be. So in the control room, they are receiving data on 60 such parameters, which they think they affect this manufacturing process. And they collect this data every 10 minutes and it comes there. Okay, so they did this for 2 years. And in 2 years, there were some failures. I think in Jamshedpur, there are about 5 blast furnaces. So in each blast furnace, there have been, a stoppage a number of times. So they try to see when the blast furnace stopped functioning, what was the value of this preceding 10 minutes before, 20 minutes before, 30 minutes before, and so on and so forth. And they know that there was a failure in the process. Okay. So now they have a nice set of data of 2 years 24/7, every 10 minutes, the value of all those 60 sensors, remaining the huge amount of data. They also have a record that at so and so date, so and so time, blast furnace stopped functioning. And when it's functioned, what was the value of this of the data like 10 minutes prior, 20 minutes prior, 30 minutes prior, and so on and so forth. Okay. And when it's stopped, engineers investigate that process and they write a report that it stopped due to this factor. So maybe there was some content in the maybe in that ore was little more than what it should be. Okay. In some cases, it could be the air pressure at certain level of production was little low, and it should be. So for each stoppages of this, they have engineers recorded what was the cause of this stoppage. Okay, so this is their data. So 2 years data every 10 minutes, the 60 important parameters that influence affects the production process. Okay, and the failure records of all blast furnaces. For each failure record, they notice the value of these parameters, 10 minutes, 20 minutes, etc. before. And then after they fix this one, they know what was the problem. So this, they are trying to do some what I call some kind of predictive analytics. Okay. So now this needs a lot of methodologically, but I would say by and large, I don't know if you've studied this, logistic regression they have used, and they could actually predict quite correctly 2 hours in advance, maybe 2 hours or 1.5 hours in advance of time. That so what they do, they run this model. Actually develop this model using all the historical data. Then they run this model in every 10 minutes. Once you get a set of data, you just run the model again. And once you run the model, maybe next 2 hours of probability 0.75 or more. If it goes 0.75, then immediately that's a trigger, and engineers are taken into engineers are called, they try to fix, and also they know what could be a possible thing in this malfunctioning, or why it could possibly malfunction. So they try to fix the battery, and after incorporating this new methodological thing, which is data-oriented recommendations, this is part of data science. Okay, so about time, so I will have, I'll speak about noon at 12, so I can. So this is this power of data science. Some of the examples I will tell now. This was like to tell this work of my student. I PhD student some time back. We are working on crowdsourced data. What is crowdsourced data? I tell the exact content. This is use Python. Okay, maybe use Python. No. There is a transition from Python 2.6 to Python 2.7. And the Python claimed that Python 2.7 income is Mr. Then he was doing PhD with me, and he says, Bimal, this claim that Python 2.7 is more reliable than Python 2.6, is it true? Or how do we either prove or disprove it? Python 2.7 is more reliable than Python 2.6. So, coming to our mind, that how do we validate the statement of this Python developers? Python 2.7 is more reliable than Python 2.6. So this becomes our study. This is the data available. We try to see if you have to need some data. Is the available data. Then you found a set called bugs. In bugs, if you're using Python, then if you have any problem in running Python, then you can post the problem you faced with this Python version. So you can put a complaint there, post that so and so date, so and so time, I was in Python and I got this kind of problems. So then actually the software engineers who developed Python, they would investigate your concern or complaint. You try to investigate this problem. In most of the cases, they do not use it. Okay. But in many cases, that was the case. There was some problem in using Python. That was genuine problem. So they would try to get a solution, a solution to the user. That yes, there was a problem. This is how we will rectify. So they have a record of all these complaints. Now, some of the trivial category, so we can ignore that. That's not really a problem. But then there are problems which are of serious nature, which are not so serious nature, casual nature, but problem, casual problem or serious problem. On a date and time wise, say for last 2 years. So I think we had for Python 2.6 the past 3 years. So 3,000 such complaints recorded. You are either or not succeeding. But they were there. 2.7, 600, 2700 such data where it talks about the data time, the problem was genuine. The problem was genuine, the problem was serious type or visual type. So you have this data. But the first problem started that if I'm using Python, if I have some problem, I may not report. So this reporting is actually happening. So this is what I will call it outsourced data. So it's the data not collected by a design. So if you have to do a data collection design, then I'll probably take a sample of say 7,000 users across the globe and will ask them, what are you having a problem with Python 2.6 or 2.7? And then if more people say that this often 7, if the people having problem this often, this thing, which more less problem, that's more. But that is the basic. We have to do representative sample of users and ask them. Even if you cannot get statistical techniques in this particular. So number one, we don't know what the users. But two is if you are facing problem, you cannot report this voluntary. You just cannot get the some. I get this problem called crowdsourced data. You would see the restaurants are rated, the movies are rated, on the social on the social websites, and you would get a restaurant is getting rated 4.6 out of 5. So it's not that the restaurant has sampled a good number of their customers and asked their opinion. That's not the case. Okay. People, if they feel good, they put a comment. If they feel bad, they put a comment. Or if I want to do a give them image, just like very much the restaurant, that this crowdsourced come from representative sample. In statistics, we have that we get a representative sample. Data science general trying to do even it violate or basic methods. Python users follow complained about know how many people have problems. In that case, data and or validate Python 2.7 6. This was the challenge and received. So there are many things, but I will tell you that he used. And again, the data is actually feel for that data. That's very important. For the data. So to the data. Finally, I have an idea. The idea is very simple. The rest would be what I say, modeling, algebra, computation, blah, blah, blah. He said, I can convey this very simple idea of weaknesses. Suppose we think of two methods, two different. Come off. If I look in the error, 20 errors. Other one, serious error, followed by 5 errors. Again a serious error. After 3 or 4 casual errors. That the if you look into the file, serious errors, many casual errors in there. And what is said, if for a number of casual errors, or I would say this, repeat it because the sense. So, yes, you have a error, then maybe 30 errors, serious errors, 35 serious errors, serious errors. On the other hand, for the other one, I get a serious error. After 5 casual errors, again I get another serious error. Then I get maybe 3 or 4 casual errors, then a serious error. Then maybe 7 or 8 casual errors, then a serious error. The second one is certainly less reliable. So all you try to say that between 2 serious errors, if there are many casual errors, then this is more reliable. So that was, then he developed the whole method, model, and the measure, and then he established that Python 2.7 is more user-friendly, but it's, I cannot say that it's more reliable than Python 2.6. Because this is what science problem. Okay, how many minutes do I have? Rajashree, how many minutes do I have?
Please carry on.
Okay.
Very interesting, sir.
Okay, so then maybe I'll talk about the other one, which will take about 10-15 minutes.
No, sir, carry on.
So this was some 20 years back. Our Sundarban Tiger project, the conservator of forest, he approached us and told that now can we help them in tiger census? Okay, can we help them in counting the tigers? So we have to understand how do they count. So they have been doing some counting anyway. So that year I think they declared that we have 254 All Bengal tigers there. in the West Bengal part of Sundarbans. But from future onwards, they want to make a more methodological thing so that it runs more smoothly or more easily. So try to understand how do they do it. They're doing some method. So we went there. We went to Sundarban, tried to see what we actually do. You know, you cannot see the tigers. There's a joke there. If you see the tiger, we don't see you anymore. So the tigers stand in a line and count the tigers out of question. So you have to understand the habit of the tigers. I never knew that tigers are extremely lazy. Tigers are lazy. They don't like sun. So basically, they stay deep in the island under the hetal tree, which is the color of the hetal tree is very much like the skin color of the tigers. So it will just sit there and do nothing. Only when hungry, they'll come out. Unless they're hungry, they do nothing, absolutely nothing. Just sit down peacefully, only doing nothing. So they'll come out and then try to get a prey. Maybe a wild boar, maybe a deer, or maybe a monkey, maybe even a big rat, whatever it may be. So whatever wild things you get, so a tiger will come and get a prey and eat it. Okay, if they catch a wild boar, it can eat for maybe many days. But and then they do in the middle of night when there is no sun. So they will, in the middle of night, there's no sun, they'll come out of his hetal tree and then kill another animal, eat it, and then they need to drink water. That is the very important. Like we also eat water after drinking, drink water after eating food. So they will go to these small rivulets. In Bangla we call khari. And in the khari, they will just come down from the island to the khari and then drink water and then again go back deep inside the forest. So what captured when they get into rivulet or khari for drinking water, steps. They leave footsteps. And unless I did this project, I didn't know. Why in Bangla, most of them are Bengali, so in Bangla we are saying, Bake chule 18 kha. Okay? I understood what is meant by Bake chule 18 kha. Did this project, then I got involved and I knew what is meant by Bake chule 18 kha. The tigers have four feet. The front 2 feet have got 5 fingers, 5 toes each. And the rear ones have got 4 toes each. So how many toes? 5 plus 5, 10, 4, 8, 10 plus 8, 8. So if a tiger jumps on you, you will get 18 scratches because with the other 4 legs, you get 18 scratches. That's why it's called Bake chule 18 kha. And I don't want to say the rest of this, the police people will get angry and so it'll make your life miserable. So, and the way the tigers work, they first put the entire pressure, most of the pressure on that. They put the left hind leg first, put the pressure, and then they pull the body. Okay, so that pug mark is the most prominent, the left hind leg. Okay, so what they do in the early morning, when before sunrise, when they do the tiger sensor, they will take launches out, and there will be several launches, each launch in area of the Sundarban island. And with the binocular, they look for these pug marks. And then they will take, if they look at a pug mark, then they will take a plaster, they will just get off, take a plaster of Paris impression of the pug mark. And plaster of Paris solidifies in, so they'll bring it. So they'll just collect this plaster of Paris, just taking the impression of this pug mark. And then they bring it back to their laboratory. What is the laboratory? The laboratory is a sand bed, and take the pug mark and put it on that sand bed and take that plaster of Paris cast out. So what they've done, they've recreated the pug mark on that sand bed. Okay, then they're professional artists. Okay, who will draw this pug mark exactly the size and shape on a tracing paper, transparent paper. So each pug mark, this artist will draw this pug mark only for the left hind leg. So at Gorali heel and then four toes. So these pug marks are actually translated to as a picture on transparent sheet. They will create some thousands of such sheet because the sensor will go for 2-3 weeks. They will collect many pug marks and then they use their visual visual capability, and then they put one transparency on the other where the superimposition is okay or not. And if after superimposition they say that 1 fit on the other pretty well, superimposition is good, then they would think this is from the same tiger. And if they don't match, then they would think this is from a different tiger. So they do this physical, visual matching by superimposition of these transparencies, and then they will create what I call baskets. In each basket, they will put only those transparencies which any two of them, if you superimpose, they fit more or less. And if you take two transparencies from two other baskets, if you try to superimpose, they are not really fitting to each other. So this is what they do, and then they are counting the number of baskets, the number of tigers. So the last, just the base sensor, they have got 254 baskets, and so they conclude that 254 tigers are there. So we are very impressed with their methods, but then we tried to say something that now what could we do? Now they have come. We have to probably do more automation. We have to do some statistics there because we are statisticians. And then it will come why does data science plays a very important role there. So if you look into this picture, there's I don't have the picture, but there's a hill and there are 4 toes like this. Now how can I represent this image by what we call a number of features? So what I mean by the feature, so the area of each toe, area covered by each toe, area covered by the hill. About the centroid of each of these toes and the hill, and the distance of amongst this among this center of gravity, the centroids, so between 2 feet, the distance of the centroids, the distance centroid, and so on and so forth. Likewise, we try to define many features of this picture. We defined 46 such features for each work. Okay, and then what they were doing is actually what we call in statistics clustering. And what is the notion of clustering? Is that within a cluster, the variation will be less. Within a cluster, the variation will be more. And so what they're doing actually clustering. Now what was, you just convert this to this statistical data, and we could do that by any image processing software. The ones we defined, we just get 40 variables for these variables. So I have the data like some 2,500 rows for each pug mark and about 46 columns for each of these features for the value for each of the pug marks. Then there are softwares for clustering, many software clustering, standard things. We run it, and we get the number of clusters. That is the number of tigers. Now I'll say that what is the data science part here? Now we did it, and the number came out to very close to 250 or so. So there's not much difference between this sophisticated statistical methods using computers and those people who don't know any science at all, just using their painting, drawing the picture by the of these pug marks by a professional artist and then doing visual superimposition. So it looks the same number. But then one of my colleagues, the Prof, you know, Kumar, told me, I have a concern here. You just think of how do we put our foot on the ground. It all depends on the ground condition. Think if it is very slashy ground, the way we put our foot, if it's very dry or strong or tough ground, the way we put our feet, they are completely different. So the same me, putting my foot. If you look at my footprints, depending on the soil condition, they look pretty different. So he thinks, Malda, I think we are making double, triple, full count of these pug marks. I don't think there are so many tigers. So now this is what I call data science, and then we have to develop a new methodology. We have to collect the data on also additionally. So those data we didn't discard, we collect afresh data, where you also noted the ground condition when this pug mark was collected. And then what we did, this is a lot of mathematics and going on. We did we saw a constant clustering, meaning that the ground conditions will play a very important role. So it's my pug mark is not my signature. My pug mark with the ground condition is my signature. That was missing, and after we adopt this thing, and then final number comes out to be, won't believe, just 90. From 254, it comes down to 90. And if you make a confidence interval, that's what we should normally do, not only a point estimate. The upper limit is 105. Lower limit goes to 72 or 73. So the number of tigers could be anything between 2 and 109, but not beyond 105 for sure. The official count was 254. So the Sundarban forest people, they're very upset, and they say that we don't accept their method. They have rejected our report. It was when announced in the newspaper that ISI has done a very bad job, and ISI has given a horrible method, and the number of tigers estimate becomes 90 instead of 254. So we didn't contest. After 2 years or so, they came back to us, said, no, sir, I think you are very right, but it was our strategical thing. The amount of grant we received from this UN body was directly proportional to the number of tigers. So we are receiving a good grant from the UN body for preserving these tigers. Now, if 254 becomes suddenly 90, our grant will go down. So we had time to cope up with the scenario and then declare. And now if you go to Sundarban, you would say the number of tigers the same, 102 or 103. I visited Sundarban last year, and there they show the number of tigers is probably 100 to 103. It's not more than that. So from the mark, the number of tigers. This video is what they call data science. But these days they have even developed further. Not only pug marks, they take camera trap, they take the picture of the tigers. So now they take there are camera traps there in this Sundarban area, and hopefully they can actually track. If they do so, they get an image. They do this parameters from images, and then do the clustering, and that's probably easier because the camera traps probably will give you a much correct idea about the tiger. But the number is around 100 only. Okay, so I'll stop now. If you have any questioning, I can allow people to question for me 5 minutes, 10 minutes, whatever is permitted by. Up to you now.
Sir, thank you very much, sir, for your valuable speech. Sir, বড় তাড়াতাড়ি শেষ হয়ে গেল স্যার।
না, আমার তোমার তো মানে আরো স্পিকার আছে না?
আর বাগে চলে 18টা আরো শুনতে ইচ্ছে করছে।
পরে অন্য কোনো ইনফ্যাক্ট আমার একটা প্ল্যান ছিল পদ্মজার বাড়িতে যাওয়া আমার সপরিবারে। আবার মানে পদ্মজার মেয়েও আমাদের খুব ডিয়ার, হ্যাঁ, আমাদের যাওয়ার সেটা তো আর হলো না। আমাদের তো অন্য স্পিকার আছে। হ্যাঁ হ্যাঁ এখন honest আমি সব বলে ফেললে ঠিক না, that's not fair. আমার ধারণা a glimpse of what is meant data science and what we are trying to handle the kind of real problems in that domain. Okay, can you question করতে চাই for 5 minutes and then you have other two speakers, you have to justify them also.
Malad, কোনো questioning হবে? Malad?
কোশ্চেন তেমন কেউ করেনি। এখন কোশ্চেন আমরা এই সেশনে রাখিনি, আমরা ওইটা ফিডব্যাক ফর্মে রেখেছি। ফিডব্যাক ফর্মে কোশ্চেন রেখেছি।
যেটা পারেন আমার ইমেল অ্যাড্রেসটা সবাইকে দিয়ে দিতে পারেন।
হ্যাঁ হ্যাঁ স্যার সেইভাবে করা হয়েছে।
অ্যাসাইনমেন্ট ইমেল and I answer 24 hours.
স্যার ঠিক আছে।
যদি কোনো কোশ্চেন থাকে they can send me an email.
আমরা ফিডব্যাক ফর্মে সেটার ব্যবস্থা করেছি।
আচ্ছা আমার ইমেল দিয়ে দাও, ওরা কোশ্চেন পাঠায় আমি উত্তর দিয়ে দেবো।
বেশ স্যার ঠিক আছে, থ্যাংক ইউ স্যার।
তাহলে এখন কোশ্চেনিং হচ্ছে না তো?
না এখন কোশ্চেন আমরা করছি না, আমরা বাকিতে।
থ্যাংক ইউ স্যার, আবার থ্যাংক ইউ, অনেক থ্যাংক ইউ। ভালো লেগেছে স্যার, ভীষণ ভালো লেগেছে। থ্যাংক ইউ। Now I am pleased to invite our next speaker, Mr. Abinash Adhikari, founder and head of Global Stack Academy. His topic of presentation is end-to-end data science process and overview. Sir, if you kindly take over from here on, please, sir.
Yes, can you hear me?
Yes, sir.
Hello all. Yes. Thank you. Good afternoon. I just like to start with due respect to my teacher, Professor Padmaja Pal, Professor Chandrasekhar Roy, and Professor Shobhendu, along with Principal of Triveni College, Vice Chancellor of International University, and Professor Bimal sir. And first of all, this session is pertaining primarily to data science prospects, right? So let me start with an example. Like when I was working in a project in Indian Statistical Institute with Dr. Buddhadev Bose, I met with Bimal sir, and I got my first job in actual as an actuarial analyst. Though actuarial science is different from statistics, but Professor suggested me that yeah, you can join there, and next year probably you'll get 2 times hike, then 4 times, then 6 times, then probably 8 times 69, and so on. And trust me, the hike that I got after say within 6 to 7 years was more than 500 to 600%. I still remember, and I thought to cite that, because so that it motivates you, like why you should read statistics and why you should adopt this as a career, and you can shine there like anything, right? And that's how the data science is very, 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 very important in today's era. And statistics and data science is being applied almost everywhere, whatever industries you can think about. So how we have structured this next 3 presentations is, first I will talk about the data science overview, like what data scientists do on a day-to-day process of machine learning project, and then taken by Saikat, who will talk about the applications of data science in several industries and probably cite some examples. And then we'll take you through a small case study which can align to what you are studying during your graduation, right? So I'd like to present my screen. Let me know whether you can see it. Just 1 minute. Yeah, can you see my screen? Is my screen visible?
Yes, it is visible, but please put full screen, sir.
Okay, yes. Let me put in full screen. Okay, I think it's okay now, right?
Okay, correct.
Yes, sir, it is visible, sir, no problem.
Okay, so my mission, first of all, for all of you, I'm the student of second batch of statistics development from Raniganj Devi College. I passed in 2002, and right now I'm heading a data science team, and I'm the founder of Global Stack Academy. I have 16 years of work experience in almost all the industries, and I work in ISI, CCS, IBM, and many other MNCs. So Being a statistician as well as data scientist, I got to work in many interesting projects which I can cite. But first of all, let me tell you what is data science about. I mean, what is data science? Why data science? Components of data science process, and end-to-end machine learning. Right? I'll try to cover quick essence and as rightly discussed by Professor Bimal sir, Vice Chancellor, Principal, I'll quickly summarize. Data science is nothing but an advanced application of statistical science to extract meaningful information and insights from data, right? And this data science is an interdisciplinary field which is again coming from statistics, coming from mathematics, coming from information science, coming from computer science. When you're merging everything, when you're merging your domain knowledge, when you're merging your business knowledge, and then you are creating an advanced algorithm, and that algorithm you are inferring about the population, and you are getting a future prediction. That's called data science. And very brief summary. Now, why data science? By applying data science, you can extract meaningful information from data, be it structured or unstructured, right? Then you can automate the process. You can reduce in a tremendous amount by a tremendous all the manual. You are removing the manual process using statistics. It is certainly for the company, for any and as Professor Bimal said, the tiger, you can get a better prediction using data science and machine learning. It's going to give you higher efficiency, right? It's more important for any industry. It's not, if the process is not efficient, that's not a good use of machine learning. So our aim should be efficiency, power. Do we use to, but we want decision making power. Our decisions are not wrong, and it's and then sorry. Okay. And finally, it is to make our life easier, because if we achieve all of the things, then certainly it's going to make our life easier. And concepts of data science, learners are primarily shown this, like statistics, machine learning. Okay, statistics you all know, visualization you all know. Machine learning explores the study and construction of algorithms that can learn from data and can get predictions for the future. And what is deep learning? Deep learning is the advanced application of statistics, visualization, machine learning, and you are making the intelligent so that it the human. That's why applying methods like is called artificial. And if you quickly process, this is cross industry important thing is business, and you can question out of command, like is you and the day-to-day, what is the kernel process or approach that is right, right, or where we can make an, and then you will evaluate a lot of data requirements, like what are the data that you need for your analysis or for building data science or machine learning model. Once you understand the data requirements, collect data from various collection from databases. It could be in flat files like Excel file, CSV file, or say .NET format, .txt format, or sometimes it may come from Oracle database. Sometimes it can come from data. Sometimes it can come from big data, from Hadoop, Spark, etc. Don't worry. These are all terminologies which are important to manage data. That's all. And once you collect data from the lead sources, then you should have a very good understanding of the data collected, right? And finally, then the next stage is you prepare the data for analysis. Like Professor Bimal said, we all can collect primary data or secondary data, but it's called raw data. Raw data sometimes are in hazy pattern or haphazard pattern and structure. For your next analysis or server building, So data preparation is a very important step of a machine learning process. And before proceeding for modeling, so from business understanding till data preparation, 80% job lies here. 100% effort put into your machine learning project, you put 80% of the effort from business understanding till data preparation. But when you actually apply modeling or machine learning algorithms, that's only 20% rest, right? So in understanding step, like from business understanding is the most important step. Otherwise any machine learning project will fail. And in the industry right now, the rate of failure of a machine learning project is 70%, and sometimes more than that. And primary reason for the failure of a data science project is improper understanding of the business, improper understanding of the domain, improper understanding of the data sources, improper preparation of the data, and that causes all failures, most of the failures, right? You prepare the data, you go for modeling, and then you may have a lot of models, right? When I'm talking about models, as of now, think about all the statistical algorithms which you are studying, right? Say Bayes theorem, say probabilistic model, statistical invariance, descriptive statistics, central tendency, dispersion, etc., right? And then out of so many models, you evaluate like which model is working better as per my current business problem, because problems may be same, business problems will be different as per the industry, right? Sometimes you can you want to predict whether a new customer will default to the loan, or whether you should give him a loan or not. Sometimes suppose you're in a bank, you have a lot of products, and you want to predict whether new customer will subscribe to your this product or that product, kind of. So the problem statements are different, and the scenarios are different. Sometimes you may have continuous data, sometimes you may have discrete data, sometimes you may have binary data, sometimes you have multinomial data, right? Sometimes univariate data, sometimes you may have bivariate data, sometimes you may have multivariate data. So you see my point, like different scenarios, different patterns, different structures, different problem statements, different modeling, right? Algorithms. That's what I'm talking about. So you may have multiple models. You evaluate which model is working best as per your problem statement. And then once you're done with still evaluation, you found your best model, and then you deploy either in your local system or in your server, be it Linux server, be it web server, or in cloud. Like you might know about a lot of cloud platforms right now, Azure, Amazon, Google, and many more. And finally, you have a feedback mechanism. A feedback mechanism is nothing but like whatever modeling or algorithm you have chosen, whether it is working perfectly fine or not, and whether it is able to predict even for the future data, because your future data, future pattern will be different from the ones that you used for modeling, right? So you need to continuously check that. Like you need to have a feedback mechanism. You predicted earlier is working well for future data. If not, then you need to manipulate, and that's what called parameter tuning, right? Or say enhancing the model parameters. But that's all about the machine learning process, data science process. This is called CRISP DM approach. Now there is one more approach like KDD, knowledge discovery and databases. It's a simpler approach compared to CRISP DM. Like first we have data, the selection of the variables or important parameters. Then you apply some transformation, like you know about box transformation, log transformation, square root transformation, exponential transformation, 1 by square root transformation, and so on, right? And then once you select data, once you prepare data, once you transform data as per your need, then you apply the right data mining algorithm. Finally, you evaluate, and then you extract knowledge from your previous steps. That's a simple KDD approach. There is one more approach, is Six Sigma approach. You might be knowing about Six Sigma. There is important aspect. DMAIC define. First, you need to define the problem and what is your baseline, current baseline, and then you measure like what's the important parameters of the baseline, and then you analyze like what are going wrong, or what are the important parameters that might be required for your prediction, etc. Then you improve your model, and then finally you control the model. Control means again it's relating to feedback mechanism, right? And one Six Sigma is like that. 6,91,462 defects per million opportunities. That means you are able to check getting accuracy of only 1%. Why do we prefer 6 sigma is like only 3.4 defects out of million opportunities? That means the yield rate of 99.99966%, which is very high. So in industry we prefer 6 sigma. 3 sigma is also because it gives you yield rate of 93. So these are different. There are more. And let me tell you, data scientist on day-to-day basis. So there are, I have like initial. Let me first is stakeholder interaction. Who is stakeholder? Your stakeholder could be your, I don't know your stakeholder is college, right? My stakeholder is my clients. I mean, they could be bank, could be insurance company, could be a utility company, could be a retail company, could be a CPG company. I mean, many more. And then interacting with stakeholders will let you know like what they're currently doing, what is their business process, what they are doing on day-to-day basis. Help you to generate the interest in machine learning idea. And out of those machine learning ideas, you will try to understand what are the business impact, because from the same process, from the same stakeholder, probably, and your understanding, you can come up with 10 ideas. Are ideas really important? Because idea impact compared to idea 2, compared to idea 3, etc. and so on. So out of those 10 ideas, you need to prioritize. ROI is based on business impact, efficiency gain, right? ROI, return on investment. And once you calculate the ROI for these 10 ideas, and best idea you will choose, like which is going to give you the highest impact in the business. So this is the initial phase. Once you go from the initial phase and you finalize the idea, then you choose the project. Okay, you clearly define a problem statement and define the scope. Then you architect the stakeholder, get their approval, and then you finally select the team. And for data science team, there will be a lot of roles like there could be. So now you can ask me like all the different career aspects for you. There are different multiple aspects. Like you can be a data analyst, you can be a scientist, you can be a data engineer, you can be a programmer, you can be a software developer, you can be a big data expert, you can be a cloud expert, you can be a visualization expert. So your future is bright because you are in statistics. Your future is very bright. So you select the best team for your data science project, then it will go to POC or initial analysis phase. In the POC phase, you will understand a lot of data sources and the valid sources of data. You must get the representative sample of the population, so go for the representative sample always, right? Then you collect the data and manipulate data, and you do preliminary analysis and visualization, which you do using descriptive statistics. You generate initial reports using descriptive statistics, and you present to the stakeholders, or you get to know about an initial understanding of the project that you are solving. And then where the machine learning is coming in, once you get to know like what is your data depicting, you go for data wrangling. Data nothing but you are manipulating, you are putting extra feature, like Professor Bimal gave an example like soil condition. That's an additional feature. So getting incorporating additional features is very important. Otherwise, it can go to a very extremely failure mode. And then you choose features, like features are most important for your model, and you go for data transformation, either log transformation, curve transformation, box transformation, and so on. And then you go for model selection of so many models. You go for model validation. You predict. Once you are able to come up with the best model, you present whatever you've done to your stakeholders, and then based on your approval, you go for deployment. And once you deploy, the machine learning project is working well, and you are very happy, right, that your project is going on. But sometimes in near future it can go wrong also. Don't worry again. You have the process of feedback mechanism. You have the process of control. You can control that, right? And this is advanced step. Like once you apply the machine learning model, our objective is to lot of reusable components, because we believe in reusable components. Suppose a same project or similar project can be started from scratch. But question is, why should someone else has already developed something, right? So why not instead consider that as a base and then enhance that? That's what we believe, we promote. we promote reusable components, and we create reusable components in APIs. These are computer programming topics. We put DevOps, development operations, we put MLOps, we take it distributed and scalable. What is distributed? Suppose using statistics, you just work in a sample that's only for one scenario. But I have many customers, say crores of customers or some millions, billions of customers who are hitting my machine learning algorithm at the same time, like you are hitting Google, right? So there could be billions of customers hitting Google at the instantly same time. How Google is able to handle that kind of scenario? It's nothing but distributed and scalable. Like they have a lot of different distributed servers, and the load of model building, the parameters tuning, it's distributed among several machines, right? And then finally, we are monitoring also. Google is also monitoring continuously. They are doing maintenance continuously. Otherwise, Google will fail. We people search trillions of search per second, say, right? It may fail any time. That's why monitoring and maintenance is very important. And then they are putting in cloud everything they have their own from Google Cloud. And finally, as I always talked about, like improvement, feedback mechanism, control. That's called continuous improvement, ongoing process. That's the end of this presentation.
Thank you. Thank you, Mr. Adhikari, for your valuable speech. Now I am pleased to invite our next speaker, Mr. Saikat Mukhopadhyay, Senior Expert Data Science, Northeast. His topic of presentation is Who uses data science and what for? If you kindly start your speech, please. Please, sir. Sir, are you here?
Yeah, good afternoon, everyone. Hope you can hear me well.
Yes, yes.
Also,
yes,
I have
audible.
shared my screen. Hope you can see me that as well.
Yes, all are visible. Yes, all are visible.
Okay, great. So, no, thank you for the kind introduction and this invitation. It's always a pleasure to connect with your alma mater, especially the teachers. So, first of all, thanks for this opportunity. So, today, I'm just trying to share some of the perspectives that we have, that whatever we are reading or maybe will be reading in the textbook, be it just a simple statistical treatment of your data or statistical modeling or data science, there are some practical application in the industry. So let's explore how like who actually uses the data science and for what they are using. So that's a standard disclaimer slide. So what I'm presenting right now, so all are available in the public domain, and I just have compiled a few of the information from here and there, and it's nothing to do with this novartis point of view. So let's start with what Abinash has mentioned, Google. And not only the Google, but all the search make use of data science algorithm to deliver research in a fraction of seconds. So had there been no data science, Google wouldn't have we know today. So as you see, they are actually mining a billion of results in a fraction of seconds, 0.67. And most importantly, there is a big prize money if you can just reduce the time in a decimal point. And also, as you know, Google is not only into the internet's business, they have their footprint in the healthcare as well. So some of the machine learning algorithms just accurately identify the metastatic cancer. And as you can see, they developed something called Lina just to accurately identify the metastatic cancer. And this just see the accuracy level is 99%. And also, as I'm coming from healthcare industry, so just to share another example from the similar domain, that Ankara Medical. And what Ankara data scientists they actually mined the 15 years data on diagnosis, and Ankara algorithms learn suggest the treatment cancer patients. Next, another big shot, Facebook. They are using their data science capabilities in the different domain, but what I feel that one of the field that they are quite advanced in the image recognition. So whenever you're uploading your photo, you usually get all this, getting this suggestion to tag your friends, right? So all these automatic tag suggestions are actually coming the face recognition. And I believe this is a quite familiar screenshot for all of you, the Amazon systems. So you will get a kind of a bought the customer who bought this item, also bought this, and maybe some sort of a recommendation for you based or inspired by your browsing history. It's a similar case for your Netflix, and I believe this is also a well-known screenshot for you. You'll be having some sort of for you in the Netflix movie, and YouTube, similarly for the Twitter and the Google feed and all. So all based on backend, actually running some sort of a data science and the principles. So another good example, it's and this Uber Eats, they are also using this machine learning and advanced statistical modeling just to satisfy their customer. So not only this tech-savvy startups, there are many examples from these government agencies because they have also realized and also started using the decision making for their daily uses. So one of the examples equivalent, they use this equivalent platform to have a data-driven crime predictions. Not only is equivalent, another repute organization in US, that is ICE, Immigration and Custom Enforcement, they are also using, you can see the raw data, the artificial learning capabilities for this recognition. There are many more examples. I believe being a student of statistics, that is well known for you guys that how a group of data scientists worked for a single goal to re-electing um, Obama as a president, right? So there is a story, there is a news, it's already available in the public domain. Also, you can use predict analytics to predict the crimes. You can predict when or where the violent crimes will be committed in future. So that's the kind of in that particular area. There are many examples, like even if you can also predict the juvenile crimes with the help of the predictive analytics and data. But already there, since you can see it's a published paper from 2010. Now, I feel and like with an example, I think data science reached to a superhuman level, that is NLP, natural language processing. You know the story about Google Home, Alexa, and Siri, and the thing that at the background they are doing recognition, natural language algorithm. Best part is that whatever the algorithm Google is using, that is also available in open source format. So you should also learn actually how to use them. But also what I felt the key milestone in that area of data science is the launch of GPT-3. GPT stands for Generative Pre-trained Transformation, is the third version by OpenAI. And just to give you some kind of a context, like what Bimal sir also mentioned, one of the examples from the steel industry, right, using 60 or 70 parameters. So conventional empirical model like regression, classification, maximum we can use probably 10, 20, 30 or 60 parameters, but you just to feed the data. But now see the capability or actually the enhanced capability of the data science, we can deal with 175 billion parameters of the synapses. So already we reached to a superhuman level. And if you can refer a published article just 2 days back, actually, and they publish this at ideas, AI, and like how they are using this GPT-3 platform for generating their business ideas. So, so world is moving fast, and this paradigm is changing, and world is now for the first mover and the early adopters. So if being a student of statistics, if you are really interested to pursue your career in that space, that means data science space, get your fundamentals clear. That's key. And be a quick learner and maybe a early adopters. So that's all from my end. Thank you.
Thank you. Thank you, Mr. Mukhopadhyay, for your coming to this page. Now, I am pleased to invite our next speaker, Ms. Srijita Bose, Deputy Manager, Advanced Analytics Team, Deloitte. Her topic of presentation is Application of Data Science, a Case Study. Ma'am, if you kindly deliver your speech, please. Srijita, are you
Sure.
there?
Yeah, ma'am, I'm here. Can you hear me?
Yes, yes,
And is my screen visible?
yes, yes, yes.
Yes. So I was just saying that please don't refer to me as ma'am. I have been your student registry, ma'am. So with my all due respect to all the respected professors and my heartfelt gratitude to Poddaja ma'am, so I would start by saying that it's an honor for me to talk here in such a platform, and all my thanks to Poddaja ma'am for this. I have been a student of PDB College from 2009 to 2012, and then thereafter I moved to University of Kolani for my masters, and I passed out in 2014. And since then, I have been working in the corporate world. The first for the last 4 years with Deloitte in the advanced analytics team. While my seniors and Professor Bimal sir has spoken a lot about data science, its applications, the overview of machine learnings, I would talk about a particular case study, and I have chosen knife-based classifier model because I feel this will be something which will be able, all the students will be able to relate to it because it's a very simple one. All our students, once they move to masters, they will learn regression techniques, linear regression, logistic regression, and then they will learn applied multivariate techniques, and they will move to principal component analysis and factor analysis. um, me but at the graduation level, I would say since we all know Bayes theorem, so I have chosen such a classification model which is based on Bayes theorem. So what I will be talking about broadly today is, while we give a quick glance to the Bayes theorem, I'll talk about the classification technique, the algorithm used by this classification model, one example to understand how this algorithm works, and then we'll move to the case study. Now, a quick revision to Bayes theorem. So when we have, say here, K mutually exclusive classes, and we assume they are independent of each other, and we have another event B. So this is our probability, the conditional probability for B occurring given for some the events A given B has already occurred. Now, depending on this theorem, how our classification algorithm works. The Bayesian classification algorithm works. It predicts that, firstly, it predicts that all our classes, all our events are mutually exclusive of each other. And then it predicts the different categorical classes and then the probabilities of each of these events occurring given within the individual classes. Then we multiply each of these probabilities of each of these conditional probabilities, and then we use the maximum a posterior algorithm, that is the highest class, which is the highest probability. We go ahead with that class as our result. Now, how does naive Bayes functions? It follows the same steps. It calculates the probabilities for each attributes, the conditional on that particular class. Then we combine all of these individual probabilities and obtain its product. We multiply them. Once we have all these multiplied probabilities for each of the classes, Then we take the maximum one, the highest probability, and then we go ahead with that class the answer. So now, while this could be very vague at the broad level, now let's example. So this is just an illustrative example for all of us to understand this model. Say we have a data where we are willing to decide whether weather conditions of a particular day are favorable to play tennis or not. So we have four parameters. We have outlook, we have temperature, we have humidity, we have wind. So say for the if we take the first data point, if it's sunny, if it's hot, and if it's humid, the humidity is high and the wind is weak, then we do not play tennis. So here we have such 14 data points on which we are going to train our model, and we are going to identify this particular case, like when we have an outlook sunny, temperature is cool, humidity is high, and wind is strong, is this condition favorable for us to play tennis or not? Now, how are we going to do this using a knife blaze classifier? So now, how do we teach our model to identify? See, we calculate the probabilities in each of these cases. For outlook, we have our probabilities. For temperature, we have our probabilities for each of the classes, for yes and for no. Here it's a binary class. So we have, for each of these parameters, we have our individual probabilities. Now we go to the knife Bayes algorithm. So like we said, using Bayes theorem, we will be calculating the products of all of these individual conditional probabilities. So for the first case, we take the product of each of these. Like if we refer back to the last slide, we said we are going to predict on this case and consider conditional probabilities of each of these cases. And now we calculate the product of the conditional probabilities of each of these cases for yes and for no. Here we have two classes, binary classes, and for yes and no. And see, we have probability of no is higher than probability for yes. And we can conclude from this example that the weather condition for that particular day is not ideal to play tennis. Now, if we move on, like you can ask me, we will of course have a special condition when one particular event never occurs. Like if we go and look back at our data, we have no particular data for when the weather is or the outlook is overcast and we have not played tennis. Whenever there is overcast, we always have played tennis. So what if we have overcast and the weather condition is not favorable to play tennis? That probability will come up as zero. If we have any conditional probability zero, then the product of all those probabilities will be zero, and then we'll get the final probability for the entire class to be zero, which is not the right case because it will wipe out all other informations. So in such a case, what do? It's we treat this cases just as we impute missing values in our data. When you will work on real life machine learning or data science algorithms, treating missing values is a big thing. Like it's a big portion of data preparation. When Abinash mentioned that data preparation is a very integral part of building any model, missing value treatment is one. Like missing value treating outliers and all of this, these are very important part of data preparation while developing any model. So here in this case, we impute these values in the similar way. We bring in one case, add one case for all those cases which are not there, all those combinations which are not there in the data. Here in this case, yeah, overcast was not there for no place equals to no, and then we just add one case so that the probability is however very low, but then it is never zero, so that the percent becomes zero. Now we move on to a case study. I hope the basics of Bayes classifier are somewhat clear now. Here it's data set where we are going to talk about predicting whether the conditions, like the inputs received from say a sample of 232 people, is indicating their preferences towards any political party in America, whether they are inclined towards Democrats or they're inclined towards Republican. We have 16 variables, we have 232 data points, and our output is binary classes, Democrats and Republicans. We have to predict their inclination towards Democrats or towards Republicans. This is our data. All our variables and all our data are Boolean. Now, how do we do it in R? It's like I have done it in R. You can do it in Python. You can do it in SAS. And you should probably learn R and Python or at least any one of the programming languages before you go into this, before you go and start working in the industry. This is a quick glance of the code, a very short code here. Libraries, we refer to the libraries, whether you are using R, whether you are using Python, we have to import some libraries before we build any model. They are the ones where all the functions and the codes are stored. We pull in the data, we check its dimension, and then we train the model on 200 rows. Remember, we have some around 232 or 234 rows. So we will be training the model on 200, and on the remaining data set, we will be validating. We'll test, we'll predict on the remaining and test like whether our model is accurate or not. Now, we build a naive based model depending on this, and then we predict on our test data set. On the remaining data set, we predict our model on the remaining data set. And then to validate whether our model is good or bad, whether its outcomes are reliable or not, we have something called a confusion matrix. Like, this is a very broadly spoken matrix in our industry. So the first thing which we see is the confusion matrix. So if you try to understand, like here in our columns, we have our actual cases, and across the rows, we have our predicted cases. So in real, we had 16 cases of Democrats, which were actually in our data, they were Democrats, and our model has also predicted them to be as Democrats. Then we move on to Republicans. We have one Republican case actually in our data, which our model has predicted to be a Democrat, which is an error. Now, if we move to Republican, we have 12 cases, which in our real data, they were actually Republican, and our model has predicted them correctly. And then we have 3 cases where they were originally Democrats, but then our model has predicted them to be Republican. I hope this confusion matrix is clear to all. Now, how do we calculate accuracy? We calculate our accuracy as Democrat cases and the 2 Republican cases divided we have. This is our model accuracy. Here, 0.875 is a good enough accuracy to go ahead with this model. Our no information rate. Now, what is our no information rate? If we had no model, if we had no training the model and nothing, no statistical technique or no classification or anything, had we considered a random allocation of these classes, then our model would have given us a 0.593 of an accuracy. So it's intuitively clear that our model always have to be greater than the no information rate. Otherwise, it makes no point. If a random classification is giving us 0.5, then and a accuracy less than 0.5 is obviously not good. So accuracy, the first criteria of accuracy is it has to be significantly greater than no information rate. And then we move to some other statistics. I'll talk about the ones which we always refer to while validating a model. There's sensitivity, specificity. So if broadly talk about in the next slide. So what is our sensitivity? Sensitivity is our true positive rate. In this case, how many are the correct observed positive? Positive as in here in this case, we are referring Democrat as positive. We usually for our convenience call this binary as 1, 0. 1 we refer to as positive, 0 we refer to as negative. Positive, every time I am referring to Democrat. And sensitivity is basically our true positive rate. Here in this case, it's 16 by 19, like you can see. 16 cases have been identified correctly out of the total number of 19 Democrat cases that we have. Specificity is our true negative rate. We have 12 truly identified Republican cases out of the total 13 actual Republican cases that we have. So 0.8 and 0.9 sensitivity and specificity is pretty good enough. There are some other addition parameters as well, which are not very widely used, I would say, but yeah, we can always consider that how many are correctly predicted positive cases and how many are correctly predicted negative cases. So, and prevalence is 1. So these are this is a very short case study. I haven't used any industry specific data to explain because I wanted this to be simple and lucid for all the students who are a part of this webinar. If I have to give you some examples of cases where we can use this in the industry itself, one would be text classification. Like there is something called sentiment analysis and text classification. In text classification, say we have news data, and we have to classify the data in 3 categories. It's sports, it's media, and it's politics. With if we train the models on certain parameters, such a classification model will be able to give us an output by classifying each of the news entry in three categories. Then broad application of classification is in the banking industry, as Avinash also mentioned. There is no financial institution, there is no bank who doesn't use a classification model. Every bank, whoever lends loan to its borrowers, to its customers, will have to have a credit score. Like they have to have a classification model to decide like whether they will give or not give loan to a particular customer, depending on the demographics and the past bank transactional history of that particular customer. They will always have to take this decision, like is this customer capable to repay the borrowing amount, the loan amount. So these are more detailed models, they have a lot of parameters. Then, to give you another example of the telecom industry, say Geo wants to identify how many of their customers are going to leave them in the next 2 or 3 months. They will train a model based on their past data of 2 years, and they will identify how many. They will train the model in both the cases: customers who are continuing to avail Geo, and customers who have migrated to say some other service provider, Vodafone or Airtel. And then this model will identify, will be able to predict which are the customers who needs to be red flagged now, which are the customers who are likely to leave their service in the next quarter. And the Geo can likewise take marketing strategies, and they can give promotions, and they can reach out to the customers individually to control this churn, to retain this customer within their service. So these are some broad level examples that I quoted. And I would like to conclude my session, my presentation. Any questions, you can always reach out to me on my email ID. Thank you. Thank you so much.
Thank you, Srijita, for your valuable speech. Thank you very much. Now, now I invite Dr. Padmaja Purkast Pal, Head of the Department Statistics, TDB College, to deliver her speech. She is the prime mentor behind this webinar. Ma'am, if you kindly take over from here on. Madam, 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 can you hear me? Madam? মলয় সব ঠিকঠাক আছে?
সব ঠিকই আছে, ম্যাডাম তো আছেন, জয়েন করে আছেন।
Madam, can you hear me?
Maybe you can unmute her. She's muted probably.
Oh, madam, please unmute yourself.
Madam?
I cannot unmute. I think
Madam,
she is
is there any
unable.
problem? একটু চেষ্টা করে দেখা যাক।
ওকে একটা ফোন করো না, ওকে একটা ফোন করো।
Yes sir, yes sir.
হ্যাঁ।
Yes, he is presenting. She is presenting. Madam, please unmute yourself.
Actually,
Yes.
Thank you, madam. Thank you.
The statistics was initiated in 1981 when only general courses were taught, and Professor Chandrasekhar Roy and Mr. Pati Bakshi, they were the teachers, together with Mr. Shubhendu Sarkar. And our department flourished at that time because lots of people studied economics honors and also maths honors students. They all took statistics as a pass subject. But and our honors course was started in 1998, and in the beginning we had students who really wanted to learn the subject. But gradually, with the opening of private engineering colleges, the number of students studying statistics has gradually dwindled. But whichever students we have, they really want to learn. They are very serious, and they had requested me to arrange a webinar where something new would be said, and uh, which would be career oriented. Well, I was contacting the alumni of the statistics department to form from the profile of the department. My students, Abinash, Saikat, and Srijita, they all expressed a lot of interest in joining the seminar. But first of all, I asked Professor Bimal Roy if he would uh, talk about data science to our students, because he's a wonderful speaker and he kindly consented. So after that, this entire webinar was planned with the kind permission from our principal, Dr. Ashish Kumar Dev. I hope everyone has enjoyed the webinar, and Bimal, thank you for staying right through. Okay, I end here. Dr. Sharbindu Bikash Dhar, who is our IQAC coordinator, will give a vote of thanks. Thank you, everybody.
Madam, please stop presenting. You can click on the stop presenting.
Okay.
Yes.
Hello, am I audible?
Yes, audible.
Thank you, madam. Now we have come to the fringe of this program, and it is my proud privilege to propose a vote of thanks on this occasion. I, Dr. Sharbindu Vikas Dhar, coordinator IQAC, of Triveni Devi Bhalotia College, Raniganj, extend a very hearty vote to all speakers for gracing this webinar through their august and sharing with us your experiences today. I must mention our deep sense of appreciation and gratitude to Professor Sadhun Chakraborty, Honorable Vice Chancellor, Kaji Nazrul University, Asansol, for his inspiring inauguration speech. He has always been there as a guide, providing encouragement at all our attempts. Today, we are fortunate enough to have a legendary person with us, Professor Bimal Kumar Roy. We are grateful to Professor Roy for his kind words and vivid discussion over the vast domain of data science with his down-to-earth approach. It is encouraging for us indeed, sir. We will like to have your kind cooperation and attachment in our future events too. Today, we are very much delighted to have our alumni of statistics department as resource persons. It is really inspiring for our present students and for we, the teachers as well, to see our ex-students today are orienting us for the future. In this connection, I would like to express our sincere thanks to Sri Adhikari for giving an excellent coverage on various aspects of and opportunities of data science, like machine learning, intelligence, etc. As these are very much relevant topics in today's industries as well as academia. I would like to express our gratitude to Sri Saikat Mukhopadhyay for enlightening us on the scenario of data science with his empirical knowledge. And we are sure that this talk will give our student community a pragmatic way. Here, I would also like to make mention that as IQAC coordinator, I welcome the proposal of Sri Saikat Mukhopadhyay to develop a collaboration between industry and academia to capitalize on the newly formed community on data science. Here I request to our statistics department along with the career counseling cell of our college to take every initiative to make this proposal a reality as soon as possible. I also seek further kind advice in this regard from since present here, including respected Professor Roy. We will stay in touch with you, sir. We are also very much delighted to have Srimati Srijita Bose as resource person today. Madam, your words are really encouraging for all. I would like to thank all the participants of this webinar come orientation for their enormous cooperation in this webinar. An event like this cannot happen overnight. It requires enormous planning and bird's eye for details. We have been backed by a team of motivated technical crew and dedicated colleagues of our college who have worked very hard to prove this venture into a fruitful one. In this regard, I would specially thank our principal sir, Dr. Ashish Kumar Devi. Without his support and encouragement, this webinar or this orientation program would not have been possible. We are also fortunate enough to have very active group of faculty members in statistics department who has planned and executed this event successfully. Here, the cooperation of our seminar committee is also appreciable, who even from their home have worked really hard during this pandemic situation. Last but not the least, I would like to thank all our students. Their involvement and participation motivated us every time we take a new endeavor. I end here with a positive hope that this is actually the end. This is a new beginning for us. Hope we now onwards will nurture the data science in a more systematic way in our college. Teachers and students of different departments from pure science as well as social sciences certainly will be benefited. Stay healthy. Thank you. That's for my end.
Thank you, everybody. Thanks to all. We are ending now.
এই জানালা খুলতো ওকে শেষ গরম লাগছে শেষ হয়ে গেল